Hi! Today we'll be doing an introduction to hypothesis testing using a one-sample z-test for averages. First, we'll cover what hypothesis testing is, why we do it, and when to use it, and then we'll go through the process by working through an example problem. So what is hypothesis testing? Hypothesis testing is the process used to evaluate the strength of evidence from a sample, which gives us a foundation for making predictions about the population that the sample came from. We do hypothesis testing when we want to determine if our assumptions about a population are correct, and the results have a wide variety of applications from business to biology. There are 5 key steps to hypothesis testing. Number 1, construct hypotheses. Number 2, find the standard error. Number 3, calculate the z-score. Number 4, determine the p-value. And number 5, state your conclusion. Let's go through each of these using an example about GRE scores. The University of Washington has an average GRE score of 210 with a known population standard deviation of 8.5. This year, 42 students took the GRE at UW, and their average score was 212.79. At a significance level of 0.05, is there enough evidence that the average GRE score this year is different from UW's average GRE score? To begin this problem, we will construct a null and an alternative hypothesis. The null hypothesis is typically the not interesting hypothesis, no changes. In this case, it would be that this year's GRE score is the same as UW's average GRE score. We would write this like this, mu equals 210. The alternative hypothesis is the interesting hypothesis, and it can take 3 forms: greater than, less than, or not equal to. For this part, we'll want to reference back to the problem. What is the interesting thing that we want to know? In this problem, it would be that the average GRE score is not the same as UW's average GRE score. We would write that using a not equal to sign to indicate that it doesn't matter if it's greater or less than, just that it's different in some way. Now that we have the 2 hypotheses, we can move on to step 2, finding the standard error. Sometimes the standard error is given to us in the problem, but often we have to calculate it ourselves. To find the standard error, we simply take the standard deviation and divide it by the square root of our sample size. The problem tells us that our standard deviation is 8.5 and we have a sample size of 42 students. Putting this into our calculator, we get 1.31. Now that we have the standard error, we can use it in step 3 to find the z-score. We're using a z-score for this problem because our sample size is greater than 30 and we're given the population standard deviation. If your sample size is less than 30, or you're given the sample standard deviation instead of the population standard deviation, then you'll want to find a t-score instead. To find the z-score, we'll take our sample mean minus the expected mean from our null hypothesis and divide by the standard error. For this problem, this would be 212.79 minus 210 divided by the standard error, which we just calculated, as 1.31. Remember to use the standard error here and not the standard deviation. Using this equation, we get a z-score of 2.13. Using our z-score, we can do step 4, which is to find the p-value. There are various ways to do this. Depending on the setup of your class, you might use a handheld calculator, online calculator, or a z-score chart. Whichever way you use, you should get roughly the same answer. Remember, we're always going toward the nearest tail when finding our z-score. Our z-score of 2.13 gives us a p-value of approximately 0.0166. But this is just for one tail. Because our alternative hypothesis says that the scores are not equal, we'll want to use both tails to take into account the possibility that our sample average GRE score is either greater than or less than UW's average GRE score. So we'll multiply by 0.0166, multiply that by 2 to cover both tails, and we get 0.0332. This is called a two-tailed test. Now that we have our p-value, we can make a conclusion. We have two options. We can either reject the null hypothesis or fail to reject the null hypothesis. To do this, we'll compare our p-value to the significance level stated in our problem. If our p-value is smaller than the significance level, then we will reject the null hypothesis. If it is larger, then we will not reject the null hypothesis. Our p-value of 0.0332 is smaller than the significance level of 0.05. So for this problem, we will reject the null hypothesis. We might choose to interpret this in context and say that we have significant evidence to conclude that this year's average GRE score is different from UW's average GRE score. Congratulations! You've successfully done a one-sample z-test for averages. Before you go, let's just review the 5 steps. Number 1, construct your hypotheses. Number 2, find the standard error. Number 3, calculate the z-score. Remember to check whether your problem uses a z-score or a t-score first. Number 4, determine the p-value. Don't forget to check whether you have a two-sided test. And number 5, state your conclusion. If you have more questions, please come visit us in the Aggie Math Learning Center. We'll be happy to help you. Hope this video was helpful and keep up the good work.